Now, my students, after that short break, let us proceed with another part. As we have already described earlier, that superposition principle can lead to different phenomena, and one of the phenomena is stationary waves. Therefore, we need to know what are the stationary waves. Now, earlier we discussed about progressive waves. That means are the waves which travel from one point to another without the decrease or increase. That means the amplitude remain the same. Now, what will happen for those transverse, for these progressive waves, when they travel from one point to another, on the way they meet an obstacles. For example, a cliff. What will happen to them? If a progressive wave travels from one point to another but meets an obstacle, this is obstacle or a cliff, what the progressive wave will do will reflect back. That means refraction will occur. Refraction will occur. That means this wave will come through where it is from. Where it is from. Previously, it was going right this way, but on the way, it meet an obstacle, therefore it reflects back. It reflects back to the source. Do you see this is the source? Do you see what nature of wave was produced here? The nature of wave produced is different from the progressive wave, but rather we forms a stationary wave. Stationary what? Waves. Now, what is the stationary wave? Look this illustration here as illustrated earlier, that I have a progressive wave moving from the source. But if this progressive wave meets an obstacle, will reflect back the source. That means one wave will recombine with another waves. One wave which is going right will combine with another wave which is going left. Together, they collectively forms another different wave, which we call it stationary wave. We are going to see why the word stationary waves. Therefore, how can we define stationary wave? Is the kind of wave, or is the progressive waves, is the wave which is formed by two progressive waves. Two progressive waves. For us to get stationary wave, we need two progressive waves. Look, we need two progressive waves, but of the following nature. We'll be asking what are the conditions for the transverse wave, for the stationary wave to be formed. We need two progressive waves. Two progressive waves. But of which nature? These two progressive waves must have the following. Must have same amplitude. Must have same amplitude. Must have same wavelengths. But also must travel with the same speed. For us to get stationary wave, we need two progressive waves with the same amplitude, the same wavelengths, and the same speed. Look here. If at all we have two progressive waves which are not having these characteristics, we are going to produce something which is not stationary. Look, for example, we have the different amplitude. Difference amplitude, that means we'll have this way, but another wave will go this way. Do you see? This is not a stationary wave. What if we have the same amplitude but different wavelengths? Look, if wavelengths is not the same, that means we have, for example, the wavelength of this one is this way. The wavelength of the incoming one is not the same as this one. That means it will fall in different points. Look, Now this is not a stationary wave. What if the speed is not the same? If the speed is not the same, it's like this way, because they are going to reach at different point at different time. Therefore, the other one will pass maybe this way. Now, this is not a stationary wave. For a stationary wave to be formed, we need two progressive waves with the same amplitude, same wavelength, same speed. That is how we can define progressive waves. Now, we have another concept. I think after this is the progressive wave we are talking about. The amplitudes must be the same, but also they must be at the same point. To fall at the same point, that means you are at the same one. You are traveling at the same speed. You have the same wavelengths. That's why you see this one is going to zero. Also, this is coming to zero at the same point. This is what we call progressive waves. Stationary wave. Now look, under stationary wave, we have this point. We have this point, we have this point, we have this point, but also have this maximum point, this one here, these 2 points here, the maximum ones, maximum point. This, the minimum point, they are called nodes. The maximum peaks this way, they are called antinode. Nodes here, antinode, node here, antinode up, and this is node. Therefore, we have two features which is formed during stationary waves. These are nodes and antinode. Nodes, antinode, node and antinode. Therefore, stationary wave is characterized by the series of node and antinode, node and antinode. Therefore, we need to know what is node and what is antinode. By the definition, node means node. Nodes. We are calling node. I said you have two features which are node, and we have another feature which is called antinode. Node, others they can explain it as no day. No day means no displacement. No displacement. Therefore, nodes is the point of stationary waves where displacement. Do you see this point? When you draw the y-axis here, this point is 0. Therefore, node is the point on stationary wave where there is no displacement. That's why we are calling nodes. Nodes. No day. That means no displacement. The word nodes. But when we talk about antinode, I said I just put it here, but it is these points, these ones here, where the amplitude is maximum. Therefore, antinode is the point on longitudinal waves where, is the point on the stationary waves where, antinode is the point on stationary wave where the amplitude is maximum. That is what we call about nodes and antinode. But we have another point to talk about node and antinode. Do you see nodes here? I said nodes, the particles, the no displacement. When you talk about no displacement, node means no displacement. If you are talking about no displacement, you are saying particles, they are at rest. Antinode, displacement is maximum. Maximum displacement, that means particles are vibrating up and down vibrations. Therefore, at node, particles at rest, no energy transferred, no energy transferring. But at anode, particles are moving up and down. That means energy is transferred up and down, up and down. That means energy is conserved because it is transferring within a specific point. Therefore, due to that, we are saying that stationary waves does not transfer energy from along it. That means from a source to a certain point, because the energy is just at node, no energy transfer. At antinode, they are just transferred up and down, but they are not moving along in the direction where the wave is moving. Therefore, in station, the word station means no energy is transferred. That is the meaning. Because at node, no energy transferred. At anode is transferred, but it is within the point. But it is not from one point to another point. It is within the area of the, look here, the energy particle at antinode, they are going up and down, up and down. Therefore, energy also is transferred up and down, but at this area, not at this point to this point. That's why we are saying energy is not transferred along the wave profile of stationary wave. Hence, stationary means no energy. We have another point now. We have seen that here at node, particles, they are at rest. But at anode, particles, they are moving up and down. What does it mean? If at all particles at rest, that means particles are compacted, squeezed together. That is the meaning. If the particles are away from each other, that means the particles are not squeezed together. Therefore, we can say at node, since the particles are squeezed together, the pressure is high. For particle to be squeezed together, the pressure is high. For the particle which are not squeezed together, the pressure is low. Therefore, sometimes we can call node as pressure antinode. Do you understand? Node as pressure, we can remember node is minimum displacement. But in terms of pressure, node can be defined as what? Node is the point where there is maximum pressure. Because at this point, particles are compacted together. They are squeezed. But antinode is the point where there is minimum pressure. That's why the particle, they can move up and what? Up and down. Also, we'll be now asked to explain why node is called pressure antinode and why antinode is called pressure node. I think you have understood that concept. After there, we want to express node and antinode mathematically. Node and antinode mathematically. Look here. Node and antinode mathematically. Because you'll be asked to explain something. Mathematical explanations. Now, these are the stationary wave we are talking about. Let us assume we have a complete one cycle. This is node, antinode, node, antinode, node. The distance from this node to the other node, which is a complete cycle, we call it wavelength. We call it what? Wavelength. Now, what will be the distance from node to node? From this point to this point, this is a half of the wavelength. Therefore, from node to node, this is a half of the what? Of the wavelength. Because this is a half of the cycle. Half of the cycle is what? Is a half of wavelength. What will be the point, the distance from node to antinode? From node to antinode, this is quarter of the cycle. Therefore, the distance from node to antinode is quarter of the wavelength. Therefore, sometimes you'll be given, therefore, wavelengths, for example, you have been given the distance from node to antinode. Two adjacent node. If you have been given the distance between two adjacent node, that means from this node to adjacent node means this one and this one. The distance from this to this point. If at all I have the distance between n and n, is like I have a half of the what? A half of the wavelength. Now, what is wavelength? Therefore, wavelength will be twice of that distance. Will be twice of that distance. What if I have the distance between two adjacent node and antinode? If I have the distance between two adjacent node and antinode, is like I have quarter of the wavelength. Now, what is wavelength? Wavelength will be 4 times that distance. Now you can have the following examples as that concept concerns. Example 1. The distance between two adjacent node and antinode on a standing wave is 2 cm. What is its wavelength? We can draw here this way. This is node, antinode. Antinode is here, the maximum point. Therefore, we have the distance between node and antinode. Therefore, if I have from this point is 2 centimeter, what will be from this point to this point, which is what is wavelength? As I said, if I have the distance from node to antnode, is like have quarter of the wavelength. That is the meaning. Now, what is wavelength? Wavelength will be equals to 4 times that distance. What is that distance? 2. Therefore, what is wavelength? 4 times 2, 8 centimeter. Therefore, from this point to this point, this is 8 centimeter. Example 2. The distance between two adjacent antinodes on a standing waves is 3 centimeter. Therefore, I have two, for example, this way. For example, it's just an example. Therefore, this is node, antinode, node, antinode, node. The distance between two adjacent antinodes, therefore, it is from this point to this point, is what? 3 centimeter. Therefore, what is this? Is quarter of the cycle. This is another quarter. Therefore, from this point to this point is what? A half of the cycle, a half of the wavelength. Because half of the cycle is a half of the wavelength. Therefore, what is wavelength? The distance from, the distance A distance is like to have a half of the wavelength. This distance we have is like we have a half of the wavelength. Now, what will be wavelength? Therefore, wavelength will be equals to twice of the distance given. NN, AA, twice of the distance given. Therefore, what will be wavelength? Wavelength is 2 times 3, which is equal to what? 6 centimeter. These questions will be asked to calculate and whatever, but you must know the mathematical treatment behind it. I hope you have understood. The rest concept is concerned about the difference between progressive and stationary. You are going to read it direct from your notes. Have a nice day. Be blessed.